The CMOS annual process, having examined the basic process steps for pattern transfer through lithography and having gone through the fabrication procedure of a single n-type MOS transistor, we can now return to the generalized fabrication sequence of annual CMOS integrated circuits as shown in the following figure. Some of the important process steps involved in the fabrication of a CMOS inverter will be shown by a top view of the lithographic mask and a cross-sectional view of the relevant areas. The N-well CMOS process starts with a moderately doped with impurity concentration typically less than 10 to the power 15 cm or minus q p-type silicon substrate. Then an initial oxide layer is grown on the entire surface. The first lithographic mask defines the annual region. Donor atoms, usually phosphorus, are implanted through this window in the oxide. Once the annual is created, the active areas of the NMOS and PMOS transistors can be defined. Figure illustrate the significant milestones that occur during the fabrication process of a CMOS inverter. The main process steps for the fabrication of a CMOS inverter are also illustrated in plate 3, plate 4 and plate 5 on pages 77 or 78. The cross-sectional features presented here were generated using DIOS multi-dimensional process simulator and PROSIT 3-dimensional structural model modeling tool by ISC Integrated Systems Engineering AG, Zurich, Switzerland. Following the creation of the annual region, a thick field oxide is grown in the areas surrounding the transistor active regions, and a thin oxide layer is grown on most critical fabrication parameters, since they strongly affect the operational characteristics of the CMOS transistor as well as its long-term reliability. After analysis of IC technologies by W. Malley, the polysilicon layer is deposited using chemical vapor deposition CVD and patterned by dry plasma etching. The created polysilicon lines will function as the gate electrodes of the NMOS and the PMOS transistors and their interconnects. Also, the polysilicon gates adds self-aligned masks for the source and drain implants that follow this step after atlas of IC technologies by W. Malley. Using a set of two masks, the N plus and P plus regions are implanted onto the substrate and into the N well respectively. Also, the contacts of the substrate and to the anvil are implanted in this process step after lens of IC acknowledged by development. An insulating silicon dioxide is deposited over the entire wafer using CVD. Then the constraints are defined, etching a way to expose the silicon or polysilicon contact windows. These contact windows are necessary to complete the circuit interconnects using metal layer, which is patented in the step after Atlas of IC technology by W. Metal aluminum is deposited over the entire chip surface using metal evaporation, and the metal lines are patterned through etching. Since the wafer surface is non-planar, the quality and the integrity of the metal lines created in this step are very critical and are ultimately essential for circuit reliability after Atlas of IC technology W. The composite layout and the resulting cross-sectional view of the chip showing one NMOS and one PMOS transistor in the anvil and the polysilicon metal interconnects. The final step is to deposit the passivation layer of protection over the chip, except for wide bonding pad areas. Thank you.